All right, today we are going to discover why cells are so small. And we're going to do that by figuring out a surface area to volume ratio for cells. Basically, cells want a larger surface area to volume ratio because it allows them to move materials out of the cell easier. I always use it as an example of you're standing in the science classroom versus standing inside of the gym. Both rooms catch on fire. Which room would be easier for you to run out of, or which room would be quicker for you to run out of? You would pick the smaller room because there would be less room for you to run across to get out into the air away from the fire. The same idea was cell surface area to volume. So let's first talk about surface area. So when you think about surface area, you think about it's whatever is surrounding the outside of something. In the terms of the cell, the surface area is going to be the cell membrane. And the equation for the lab that you're going to be using to solve for surface area is going to be length times width times 6. And you have to multiply your surface area by 6 because you're going to be using a sugar cube to represent a cell. Now you have 4 different cells, cell 1, cell 2, cell 3, cell 4. Cell 1 is only 1 sugar cube, whereas cell 2 is made up of 8 sugar cubes because there are 2 sugar cubes wide, 2 sugar cubes deep, and then 2 sugar cubes high. There's the cells are a cube, which I took a picture of so you could see the different angles of them. For the volume of the cell is what's inside. In terms of the cell, it's going to be the cytoplasm. And to calculate the volume of the cell, you're going to use the equation length times width times height. Now, I know some of you don't have rulers, and how would you measure cells through a video? So to get around that, what we're going to be doing is we're going to imagine and just basically estimate that each sugar cube is 1 centimeter wide or long. So every side of a sugar cube is only 1 centimeter. Okay, and that's going to help you calculate our surface area to volume and their ratios. I'm going to do cell 1 and cell 3 with you, and then you're going to do cell 2 and cell 4 on your own. So to calculate the surface area of cell 1, remember the surface area again is length times width times 6, again because there's 6 sides to this cell. This cell is only 1 block big, so you're going to take length was 1, and then width is 1, so 1 times 1, and then times 6 sides is going to equal 6. Then for volume is length times width times height, which again, it's only 1 block, so it's 1 by 1 by 1. Multiply them out, it's 1. Now, we're going to do a surface area to volume ratio. And when you do that, I'm going to ask you to take the surface area to volume and basically make a fraction out of them. The surface area was 6, the volume was 1, and then I'm going to divide them. And basically, your surface area to volume ratio for cell 1 is 6. Okay, now cell 3, again, is made up of 3 sugar cubes wide, 3 sugar cubes long, and then 3 sugar cubes deep. So to calculate surface area, you're going to take 3 times 6, and that is going to give you 54. Then for the volume of cell 3, you're going to take length times width times height. Again, that's 3 by 3 by 3. And that's going to give you a volume of 27 centimeters cubed. To solve our surface area to volume ratio, you're going to take 54, which was the surface area, divided by volume, which was 27. Divide it, and you're going to come out with a surface area to ratio of 2. Okay? Now you're going to have to solve cell 2 and cell 4 on your own, but I wanted to do cell 3 because I wanted us to talk about what is happening as the cell gets bigger. What's happening to the surface area to volume ratio. So as the cell gets bigger, right, so the cell's gradually getting bigger, what's happening to the ratio? It's getting smaller. So the question is, why is that a bad thing? Okay, and I'll give you a clue. Think about a mouse and an elephant. If both were left in the cold overnight, which one would be in more danger of freezing? Okay, would it be the mouse, which would be cell 1, or would it be the elephant, cell 4? Okay, and it has to do with this phenomenon of surface area to volume ratio. Okay,